Hello, I would like to talk about my work on the topic liposomal nanoparticles in high contrast of fluorescence speckle-contrast imaging and ultrasound measurement in phantoms and murine model. So, liposomal particles are bioavailable contains for the delivery of various substances. Liposomes are used as a tool for drug delivery and fluorescence labels. Due to its properties, liposome particles can be used as a contrast agent in fluorescence imaging, laser speckle contrast imaging, and ultrasound diagnostics. This is important for obtaining more research information when using different research methods at the same time, using liposomes in the simple and inexpensive way. It can also be used in the clinical practice of circulation system diseases, including ultrasound, dermatological, and neurosurgical and endoscopic studies. This work was aimed at obtaining particles for multi-proposal use in LCCI, fluorescence spectroscopy, and ultrasound diagnostics. For this task, multi-malarium liposomes were synthesized using lecithin and sunflower cholesterol by phase inversion. For fluorescence spectroscopy, liposomes with encapsulated fluorescent dye as in Y were used. I felt liposomes were used in ultrasound spectroscopy and LCCI. Fluorescence spectroscopy was used to study the effectiveness of the penetration of eosinide liposome capsules with a fluorescent label in the circulatory system when administered orally. The maximum intrinsic fluorescence of the tested fluorescent dye lies in the region of 520 plus minus 5 nanometer. Experimental studies were performed on clinical healthy mice of operant stock CD1 at the age of 5 months. For research and experimental setup based on LCCI, phantom setup was used. The phantom consists of capillary tube diameter 1 mm in suspension of intralipid 20% and liposomes and water was pumped through the capillary tube using a surge. Change in speed of moment intralipids liposome in test tube were recorded using a camera. The frame sequence were processed. For ultrasound examination and assert my lab 15 ultrasound apparatus with a frequency of 1 to 8 MHz were used. The study was conducted on phantom setup with elastic tube placed in a agar-agar gel so which in the tonic solution was paced and speed of 0 to 20 centimeters per second. 12 mice of outbred stock CD1 were divided into two groups treated with eosin Y and control dye without liposomes. The maximum fluorescence intensity, 114% of the initial level, was recorded 13 minutes after oral administration in the group of animals that received a fluorescent dye without a liposome membrane. Fluorescence did not exceed 110% of the initial level. Experimental results show that the obtained multimalaria liposome particles can increase the effectiveness of the transport material entering the bloodstream through the gastrointestinal tract after oral administration. The contrast level increased by 57% of the initial concentration of the control. The circulation time in closed system at speed of 20 cm per second was 11 minutes until an ultrasonic wave utterly destroyed the particles. Analyzing the data obtained, we can conclude that the proposed gas-filled liposomal particles can increase the contrast level by 16. These results indicate that liposomal particles can be used in fluorescence spectroscopy, in ultrasound diagnostics and LCCI. Using a single dose of particles will provide a wide range of information and suggest further invasive procedures. This is very important because this provides more research information. It is all. Thank you for attention.